Okay, I've just recorded this, and again, it didn't record, so I'm going to go over the answers with you here for a couple of the questions in the practice problems. At the end of this lesson 5.1, we had a few different equations that were going to be useful to us. We said the number of electrons equals the charge over the fundamental charge of a single electron, so that can tell us for a given charge how many electrons have we got. We've also got the current measured in amps is equal to the charge in coulombs over the time in seconds. So this is telling us how many coulombs per second have we got, which is our current. And last one we've got is Ohm's law here, which is voltage equals the current times the resistance. So our first question here says a current of 1.6 amp flows in a wire for 2 minutes. So we want to know how much charge travels through the wire. Well, we've been given the current, which is 1.6 amps. We know the time, which is 2 minutes or 120 seconds. And we're looking for the charge Q. So we can rearrange our equation here. And we'll isolate the charge and say that it's equal to the current times the time. And we end up with 1.6 amps times 120 seconds. And that is going to leave us with 1.92 times 10 to the 2 coulombs. Round to significant figures, we've got 1.9 times 10 to the 2 coulombs. Second part of this question is how many electrons travel through the wire? So if we're looking for the number of electrons, again, we're going to use this equation where we've got the number of electrons. Now here we know what the charge is, so we can figure out if we've got this given charge, well, how many electrons does that represent? That amount of charge represent? So we're going to say our number of electrons, and again, we're going to look at the absolute value of our answer here because it doesn't make sense to talk about negative electrons. So we're going to say 1.92 times 10 to the 2 coulombs divided by 1.67 times 10 to the negative 19 coulombs. Our coulombs are going to cancel out, and that'll tell us that this charge represents the charge of 1.1 times 10 to the 21 electrons. Okay, so that's going through the first couple of equations. We're going to skip a few. I'll let you go through these on your own. But we're going to come down here to Ohm's law. So we're going to use our last equation here. Our voltage equals our current times resistance. And we'll say a small light bulb is connected to 3 volts and draws a current of 150 milliamps. So what is the net resistance of the bulb? Well, we were given the voltage, 3 volts. We were given the current in milliamps, so we'll have to convert that to amps. Again, milli just means we're going to have to divide by 1,000. And we're looking for the resistance. So again, we're going to do a rearrangement of our equation here. We're saying our voltage equals our current times our resistance. And if we rearrange that, we're going to have resistance equals voltage over current. So 3 volts over the 0.150 amps should give us 20 ohms. Now we've got 20 ohms here, so we know our resistance in this next question, which is if the voltage dropped to 2 volts, what would be the current through the bulb? Well, we now know our resistance is 20 ohms and our voltage has dropped to 2, so we need to figure out current. So we're going to have current equals voltage over resistance. 2 volts over 20 ohms equals 0.100 amps. And you'll see here that we can say amps or we could say coulombs per second, because remember, our current is really coulombs. How many coulombs are going past the boundary per second? Okay, so a relatively small number of questions here dealing with these 3 different equations. We're going to talk about electrical power next, and then we're going to have a homework assignment which covers electrical power. It's also going to cover Ohm's law and electric current. I'll see you next time.